I'm at Drives and Controls 2014 for the launch of Schneider Electric's M580 ePAC, and I'm with Dave Sutton, Product Marketing for Schneider Electric. Dave, can you tell me how Schneider Electric's concept of ePAC builds on PAC technology?
Absolutely, yes. As you say, the ePAC is based on PAC technology. The E, most importantly, stands for Ethernet Backplane. So the Backplane Ethernet does deliver some significant customer benefits, which I'd like to talk you through. Should we go and have a look at the product?
Brilliant, let's do that.
Let's have a closer look at the Modicon M580 ePAC. Here it is in the flesh, as we can see in front of us. The Modicon M580 element of what you see here is just the processor part. Okay? The rest of what you see in terms of the architecture looks rather familiar. In terms of the power supplies, on the left-hand side here, the various I/O modules, the digital I/O, the analog I/O, the communications and so on, these are all common components which are shared with our entry-level PLC, the Modicon M340, which has been in the marketplace for a number of years now. So straight away, the M580, although it's fresh and been launched in the marketplace today, it's already got a very mature catalogue of I/O modules and other devices connected, which means it's ready to roll straight away. If we look at the M580 in a bit more detail, we'll see, we've talked about the 580 being an ePAC, the world's first ePAC. The significant difference here is the fact that the backplane has Ethernet on board, which means that the devices are capable of communicating across on Ethernet. Now that does bring some significant customer benefit to the architectures. Probably the first benefit that I can highlight here is the openness. The fact that the backplane is standard Ethernet IP technology means that the backplane is open for other devices and other manufacturers to plug into. We do work with a number of collaborative automation partners. Here's an example here, a Wi-Fi module. That it's very easy for our chosen partners to bring their solutions and their technologies and integrate them neatly into the M580 world. The second key benefit of the Ethernet backplane is really down to performance. The fact that the devices are communicating on Ethernet means that there's a transparent exchange from source to destination. If you can take an example, let's consider we have a SCADA system upstream, maybe a HMI touchscreen, which is communicating through the PLC down to a variable speed drive on the factory floor, and we want to display process data, variable speed drive settings and so on. In an old-fashioned PLC, then the request would go from the SCADA through the PLC, where it would need to be converted across the backplane to run across a different protocol, and then down to the drive, and then back again. So you have various bottlenecks and conversion points in the exchange of data. With the concept of the ePAC, you have direct, transparent communication from source to destination, which means that your performance is greatly optimized. And then as we're moving into the world of Industry 4, where we've got more devices communicating, more data being exchanged in real time, it's very important that we have optimized communication connectivity. And the notion of the Ethernet backplane gives us exactly that. Another important point of the ePAC is to do with security. We've mentioned that we've got an open backplane, and one of the questions that people straight away ask is, if it's open, how secure is it? There's a lot of talk in the marketplace about cyber security, so what are we doing with the M580 with regards to the risk of attack? Well, the M580 has a certification known as Achilles Level 2 certification, and that's a strong stamp of approval to say that the 580 is very robust and hardened to attack from cyber attack. It's got various levels of functionality, such as passwording, IP filtering, lockdowns, authentication and so on, which means it's a hardened device to the risk of external attack. In the rack here we have a Wi-Fi module. This is great because this is effectively Wi-Fi enabling the ePAC. More and more customers now want remote access and the ability to diagnose and troubleshoot and fault find remotely. They want to be able to use their smartphones, they want to be able to use their iPods and their Android devices. Inside the M580 we have an engine in there. It's based on HTML5 technology, which means it's ready for smart devices. So coupled with this in-rack Wi-Fi module, we can very easily connect and program and troubleshoot and diagnose faults with smart devices. What else can we see on the M580? Well, let's have a look at here. We've already talked about the inbuilt Ethernet backplane, but that extends through the green cables on the front here. We can see that we're looping across. We've actually got a redundant connection here. So 2 cables from the CPU into our first block of remote I/O, and then back again to the processor. So if one cable is severed, we've still got an alternative connection back. Copper cable is usually good for about 100 meters. If you need to extend, then we've got in-rack fiber optic modules, which we can extend the distance between racks up to several kilometers if we need to. Other elements of the M580 are on show here. We have this dedicated module here, the ERT module, that's capable of time stamping. So in terms of capturing sequence of events data to track and trace the root cause of a failure, this module can timestamp and hold all that data on board down to a resolution of 10 milliseconds.